Good morning, everybody. First of all, just one or two announcements. Our midterm is this Wednesday. Today is Monday. The midterm is Wednesday. Okay, which is April 14th, I guess. Today is the 12th, yeah. April 14th, 2021. And the structure of the midterm is exactly like the first midterm, which you have taken. So all of you have taken the first midterm, you know what to expect. I'll open the midterm at 6 a.m. You have until 11:59 p.m. I'll open it at 6 a.m. You have until 11:59 p.m., which is about, I don't know, 18 hours. Okay, it shouldn't take 18 hours. It should take roughly about a couple of hours. Okay, that's what it is. It shouldn't take more than that. You can work on it in one sitting if you'd like, or you can work on a problem, take a little break, come back and work on it. And as you take the test, on the lower right corner, right around there, you will see your score being updated live. Okay, so that's what it is. And in terms of the materials, I have gone over the materials in the class. So everything after the first midterm will be on the second midterm. I think I have included a problem from binomial distribution. Okay, that I think I covered in the last midterm, but it's a good thing to have a practice of binomial distribution. It's a useful distribution, particularly given that COVID-19 we are dealing with at the moment. Binomial distribution would be something interesting because binomial distribution is something that could be applied in the pharmaceutical industry. If you develop a new drug, you want to see the effectiveness of it. So maybe I'll make up a problem with COVID-19, maybe for the final, okay? COVID-19 problem. The Pfizer is claiming that they are 95% accurate, right? Not accurate, 95% effective against COVID-19, and so is Moderna. And Johnson & Johnson, I think it's 72% or 0.72, something like that. So maybe I could make a problem that will use the binomial distribution concept, but applied to COVID-19 vaccine that you're developing. All right, Jonathan, are we going to have a special office hours for the midterm review tomorrow? Yes, thank you for asking that, Jonathan. I forgot about it, but even as I was driving to the office, I was thinking about giving you guys a time, but I just forgot about it right now. Thank you for reminding. Yes, we are going to have a special office hour. I want to help you guys out, okay? I really do. I want you to be successful. I want you to be happy at the end of the semester, that you learned, most importantly, and you got a good grade. Special office hours. So let's do it at 6 p.m. tomorrow, okay? Tuesday, 6 p.m. It's gonna be 4/13, which is tomorrow. So that's a Tuesday. All right. So 4/13/2021 on Tuesday, which is tomorrow at 6 p.m. I'll start at 6 p.m. and take your questions as long as you have them. All right. So we will start at 6 p.m. Take your questions as long as you have them. I'll even open the old homework for you. Okay. I'm gonna open the old homework. If you missed anything, you can work on it, but I don't recommend trying to do the old homework right now if you missed anything. I would recommend going over the midterm review, second midterm review, and then make sure that the old homework that you have done, you know all of them, how to do them. And after that, if you have time, then if you missed any homework, let's say you didn't work on a problem during the regular time that I allowed you for the homework, you can go ahead and work on it. But your first priority should be to go over all the review problems. And then make sure that you do know all the problems that you have done in the regular homework. Once you are completely comfortable with that, then go ahead and work on extra problems that you have missed. So that should be the strategy. Don't try to solve the old problems now. Then you'll be spending time on one or two selected few problems, and you'll miss the entire review sheet and other things. All right, so please make sure to focus on the review problems and the homework problems. All right, that's the office hour tomorrow. And then anything else? Have I missed anything, guys? Do you have any questions about the midterm? Anybody has any questions? Alicia, any question about the midterm?
No questions.
Okay. All right. I think I covered everything for the midterm logistics. And yeah, I want you to do well on the midterm. So please study, okay? And you can email me from the system. It's not necessarily necessary that you have to wait until the review tomorrow night. You can send me questions from the email, okay? When you work on a problem, it gives you an option for email. You can email me, okay? And you can even text me, but email me first, okay? Email me, and then I'll respond. All right, so today's objective is to cover two things. Number one is we're going to create confidence interval when sigma unknown. That means we don't know sigma. Okay, and number two, we are going to cover confidence interval for standard deviation. Okay, confidence interval for population, standard deviation, and for that we're going to use a special distribution called chi-square distribution. So two things for the day: confidence interval for population, mean when we do not know sigma, and confidence interval for population standard deviation. And for that, we are going to be using a new distribution called chi-square distribution. Technically, we don't do standard deviation. We kind of find confidence interval for variance, population variance, and then we take the square root of it, and then we find the confidence interval for standard deviation. Remember, variance is the square of the standard deviation, whereas standard deviation is the square root of the variance. So you should know that variance, okay, is equal to sigma square, square of the standard deviation. Okay, so having said that, let's go ahead and get started. Sigma known. Okay, let's go. Sigma unknown. All right. Oh no, that's not sigma unknown. This, where is my sigma unknown? Okay, there it is. Confidence interval for population mean with sigma unknown. So only difference, so if you read it a little bit, I don't know if you did. In case if you did, here is one interesting thing. normal distribution, this approximately has normal distribution, okay? Z, that's why we call it Z, which has a mean of 0 and standard deviation of 1. X bar minus mu divided by sigma over square root of n, that has approximately normal, standard normal distribution, bell shape. Now, when we don't know sigma, what can we do? When we don't know sigma, we don't really have a choice. What we do, we replace sigma with the sample standard deviation, as you can see here. We replace sigma with sample standard deviation. And the difference between these two is this. If this is your bell-shaped curve that you have when you know sigma, okay, sigma known, okay, T distribution, it has the following characteristic. It is stretched bell-shaped curve. So it's kind of like this. I'm kind of exaggerating it here. So I used to have a figure where these things are drawn out nicely for different, what we call degrees of freedom, okay? As the degrees of freedom increases, this stretched bell-shaped curve kind of becomes more and more normal distribution like. That's what it is. So that is the characteristic of the this new distribution, where what we call, by the way, student T distribution. Student T distribution. This is called student T distribution. So please make sure that you're okay with it. Now, once again, the main difference is that you replace the sigma by sample standard deviation S, because if you don't have sigma, then what can you do? You really can't do much with this one, because this is not as useful. And then once you don't have it, you basically create S. All right. I mean, you use S, not create S. And let's go ahead and work on the problem. So what we are going to do, we are going to go ahead and try to do some example problems. Now I need a volunteer. So let's see, is Mijin here? Mijin?
Yes.
Okay. Do me a favor. For this data set, do you have a calculator ready?
I do now.
You do know. Okay, great. Do you know how to find standard deviation on a calculator? What kind of calculator do you have?
I'm just using the one on my computer.
Oh, the one you have a computer. Okay. Do a Google search. So let me tell everybody, you guys should do the same thing, everyone.
It has a statistics calculator.
Okay. You don't even have to use it, really. Because nowadays we do everything in a sophisticated way by doing search.
Is there a particular symbol I'm looking for?
You need to find standard deviation, sample standard deviation, okay? And it depends, the instructions are very different for different calculators, okay?
Okay.
However, because I have a TI-84 calculator, and I kind of don't know whether all of you have them. At the beginning of the class, I announced, okay, you should have one, but if you don't have one, that's okay too. If you have the money, you can buy it. It's a bit expensive, $130 or so. Okay, so.
I have a TI-83. I just pulled it out.
Okay, all right.
I don't know what I'm looking for, though. What am I solving for? Hello?
Okay, you have the TI-83. Is that what you said?
Yes, I just turned it on.
Oh, okay. So what you want to do? Well, first of all, let me show you how to find it. Find online software or online web applications so that you can find it online. Everybody, go to Google and just search for find some or find or calculate. Maybe calculate. Don't use find. Calculate sample standard deviation or standard deviation. Sample standard deviation. Calculate sample standard deviation. That's what it is. Okay. So you need to search for it. Then it's going to give you'll find several websites. There are quite a few of them. You can just plug in these numbers. They will ask you to, they'll give you instructions how to enter these numbers, typically separated by comma. Okay. Typically separated by comma. That's what you need to do. Then you calculate it. It's going to give you a couple of things. It's going to give you X bar. That's the mean of these numbers. Then it's going to give you something called S, which is the sample standard deviation. It's going to give you X bar, which is the mean or average for this data set. And it's going to give you sample standard deviation, which is S. Okay, so now in the TI calculator, which I have myself, you can follow this. If you have TI, you should do the following. Click on a button called Stat. Okay, then you'll see on the top, Edit, Calc, Test. Okay. Then under edit, there will be a bunch of selections. You select number 1, which is also edit. Okay. Once you select number 1, it will give you a list of things like that, a table labeled L1, L2, L3. Okay. And you go ahead and clear. If you have any data, what you want to do, you want to use the arrow button and clear it all the way, go to the L1 and hit clear. It will clear everything on that column. So once you are in that column, you just enter these data points. Okay, so it's 18,900. So don't put the comma. I put the comma here, but don't put it. 18,900, one data point. Then 21,300. Then 13,700. 23,400. 15,800. 17,200. 19,500. 12,900. Then 17,400 and 13,300. By the way, you guys need to know how to do it for the exam. All right, so that's why I'm kind of going step by step, showing you how to do it. So I entered all of these data points in a column labeled L1. You could put it anywhere you want, L2, L3, whatever. So I put it on L1. All right. Now, once I have done it, what I'm going to do, I'm going to hit the stat button again. Stat. Okay. Hit stat. Then this time, I'm not going to select edit, but I'm going to select calc, C-A-L-C, the second one on the top. And the first choice for this is 1. The choice 1 is 1 where stats. one var stats. You want to select that. Then it's going to ask you, it's going to give you something like this list, and then frequency list, I guess, and calculate. Now you don't need to worry about this frequency list. Is probably for something else that we haven't talked about. Now list, on the list label, you need to make sure that you have L1 selected, because that's where we put the data points. Now what if you have something else? Like on my calculator I have L4. Okay, so to select L1, what I have to do, hit the second button, second, which is the shift, right? And then press number 1. Second and press 1, that's gonna give you L1. Second and press 2, that's gonna give you L2. Second and press 3, that's gonna give you L3. Second and 4, L4. Second and 5, L5. Second and 6, L6. Second and 7, L7. Second and 8, L8, L9, and L10. Okay, that
I
kind
have a question. How do you enter the points into L1? Did you just list it and separate it by a comma?
No, just put the first number, hit enter.
Okay, mine's giving me an error when I hit enter.
What is the error it's saying?
Let me do it again.
Did you put the comma?
18, no, so 18 comma 900.
No, it's not 18 comma 900.
Oh.
It's 18,900. That's what I told you. You probably skipped that information.
Where do you want me to put the comma then?
You don't have to put the comma. I put it here for separation purposes.
Oh yeah, I didn't put a comma. I hit enter. Oh, hold on.
See, it should work now, right?
No. Clear. I cleared L1. Well, the numbers that are in L1 didn't clear out. So how do I clear those? Oh, there it goes.
All the way. Go all the way up with arrow button. You'll highlight L1, and then.
Okay, I got it. I hadn't cleared out L1 all the way. Thank you.
Okay, so now that I have L1 selected, then I press enter. Then enter. Then I highlight the calculate and do enter. And it'll give you a bunch of numbers. One of them is, so let's clear it up. One of the numbers is X bar, which is 17,340. Okay, that's the average. And it gives you a bunch of other numbers. Then there is something called S sub X. In the calculator, you'll see S sub X. All right, then just write S, which is the sample standard deviation. That is 3514.79. 3514.79. And these are the two numbers we need in order to solve this problem.
Professor.
Okay. Yes.
Wouldn't it be simpler, at least in my perspective, because I'm a more visual learner and I'm pretty sure other people are too, wouldn't it be better to share the screen and show how you would do it online if you're suggesting using an online calculator?
Yes, I can do it. The reason I'm not doing it right now, because if I get out of my screen, Zoom doesn't allow me to share multiple items on the same screen. Okay, or at least I don't know, honestly. So if I try to do that, it's gonna go ahead and kick me out of this. Then I have to go back and upload it again. But I can do it. I'll do it. Okay, so let me do just one problem, and then maybe I'll go online and search for it and show it to you. All right.
Okay.
Okay. So what's gonna happen is this. So for now, assume these two numbers, X bar and S. X bar and S. This is something you can just use ordinary calculator and do it. And for finding the standard deviation, you have to use a calculator that can do standard deviation, something more statistics, has some statistics functions, okay? Now, let's go ahead and work on it. Now, let me go back, and there it is. There's the formula that we need. X bar plus or minus T sub alpha over 2 times S over square root of n. Then your confidence interval is going to be, oops, what happened? Okay, and then hold on a second. Okay. Sorry, my screen got somehow, something is happening. Okay. Then my confidence interval is going to be this. X bar minus T sub alpha over 2 times S over square root of n, comma, X bar plus T sub alpha over 2 times S over square root of n. Now this is kind of like the margin of error, kind of what we did for the case when we knew standard deviation. So T sub alpha over 2 times S over square root of n. All right. So that's what it is. And I don't know if I use the term T sub margin of error here. Okay. So now, again, this is pretty standard, by the way. Since we do not know, so sigma unknown here, sigma unknown. So that's the key thing. Since we do not know sigma, what we need to do is we need to use sample standard deviation. Remember the difference between sigma and S. Sigma is the population standard deviation. S is the sample standard deviation. We don't know sigma, therefore we have to use the sample standard deviation. So that's why we were finding the sample standard deviation, which is S. In this case, for this problem, it is 3514.79. And as requested by, I don't know who requested it, but Jerry, I guess, requested it. I'll show that to you by switching screen and showing you on Google how to search for it and find the standard deviation. All right. For this problem, we have the X bar and we have the sample standard deviation. So how do I find E, or what I will call, or E hat, margin of error, T sub alpha over 2 times S over square root of n. Now for this one, we know S is 3514.79. What is n? That's the sample size. How many data points are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Our number of data points is 10. Now, how do I find T sub alpha over 2? Now, T distribution is kind of like stretched bell shape. So you could think of it like that. Now, our confidence level is 95%. Okay. So alpha, the significance level is going to be 1 minus the confidence level, still 1 minus 0.95, which is 0.05, right? So alpha over 2 is going to be 0.05 divided by 2, which is 0.025. So we will have this and this. Area to the left is going to be 0.025 area to the right is going to be 0.025. Area to the left is 0.025. Area to the right is 0.025. Correct? Now, let's go ahead and look at it. In the last set of problems that we did when we knew sigma, when we had information about sigma, we looked at z-scores table or standard normal distribution table. However, here we don't know, okay? Here we don't know, therefore we have to use t-distribution. That's a different type of distribution. That's what I have been talking about. T-distribution, all right? Now let's go ahead and work on it. Now let's go back to the table. Everybody go back to the table, and I'm gonna clear the screen for a second and I'll come back to it. Okay, that's the table we are looking at. That's called t-distribution table. Now you remember the diagram that we have had, right? The diagram that we have had, on the right hand side area was 0.025, on the left hand side area was 0.025, on the right tail area was 0.025, on the left tail area was 0.025. So if you look at the top here, you see area in one tail 0.025, area in two tail 0.05. That's the case that we are looking at. You can look at other ones, like for this one, area in one tail 0.005, area in two tails 0.01, which would be 99% confidence level. So for that one, you'll be here. On the other hand, if you wanted 80% confidence level, area in one tail is going to be 0.1, and area in two tails is going to be 0.2. So depending on what is the total area in your diagram or the confidence level that you are using, the total area in both tails and the confidence level that you're using, that's going to determine which column are you going to be using. In our case, we have 95% confidence level. So our significance level is 1 minus 0.95 or 1 minus 95%, which is 0.05. That's why we have area in two tails 0.05 and area in one tail, half of it, which is 0.025. So that's how you determine which column you're going to go into. Is this clear, everybody, so far? How to determine which column to go to? Yes, everyone? Okay. Now what I'm going to do, I'm going to go ahead and find the row, which row to go to. Remember, our sample size n was 10. We defined something called degrees of freedom, which you can see here, degrees of freedom, df, which is always n minus 1. So in our case, it's going to be 10 minus 1, which is 9. So you keep looking in the first column and find out 9. And then if you go to the column of interest, that gives you 2.262. 2.262. That is your critical value. That is your T sub alpha over 2. Now, is everyone okay how to find this value?
Yes.
Okay, make sure that you know how to find this value. Now, what I'm going to do, I'm going to go back to my screen where I was before. Okay, so this is the problem that I was working on, right? Okay, so let's go back, and it's going to take me a little bit of time to undo all the things that I did. Give me a second. Okay, now I have it. So your T sub alpha over 2. So this value that you're looking for, it is 2.262. How did you get it? You got it from the table, right? So your T sub alpha over 2, which is 2.262, or T sub 0.025, area in one tail 0.025 is going to be 2.262. Now, this point is going to be 2.262. This point is going to be negative 2.262. Now we kind of do the margin of error calculation. Okay. Which is going to be T sub alpha over 2.262 times S. That's where I use the simple standard deviation, because remember, the difference between the last formula and this one is that margin of error E hat was Z sub alpha over 2 times sigma over square root of n. If you compare these two formulas, you can see structurally they are very similar. They are very, very similar. So this is Z sub alpha over 2. You replace it by T sub alpha over 2. And you don't know sigma, right? You don't know sigma, so you replace it by S. So that's something that's going to help you compare and contrast these two things, which is going to help you learn things better. So times S, which is 35, 14.79, all of it divided by square root of the sample size. My sample size n is equal to 10. Now, if I do the math, so what do I get? 35, 14.79 times 2.262, all of it divided by square root of 10 square root that's going to give you 2514. So margin of error is 2514.15. Okay, so that's your margin of error, 2514.15. Now your confidence interval CI is going to be X bar minus E hat, comma, X bar plus E hat. Okay, so X bar is 3514. X bar is 17,340. 17,340 minus the margin of error 2514. You know, it's such a big number that I will just ignore this 0.15. So just make it a nice number, 2514. But in the homework set and the exam, make sure that you include the 0.15. Otherwise, it may give you an error. Minus this 17,340 minus 2514. Now 17,340 minus 2514 is 14,826. 14,826, comma 17,340 plus 2514 is 19,854. 19,854, and that's what it is. So the confidence interval for this problem, I just realized that with all this conversation, I even forgot to read the problem. So assume that you'd like to know the average yearly income that agricultural field workers in Salinas, California makes, okay? So you take a random sample of 10 field workers and find the following. So you try to, so your objective here is to find out a confidence interval for average income for the population of agricultural field workers in Salinas. So you went out and collected data. So you went out and collected data, asked 10 people how much they make, okay? And you got these numbers, and based off of these numbers, you want to create a 95% confidence interval. And the process for doing it is this. Again, for the field workers, you really don't know what the population standard deviation is. Therefore, you do this calculation based on the sample standard deviation. And that's what it is. So this is where we use the student T distribution, because we do not know sigma. We have no information about population standard deviation. So we replace sigma with S. Now that we are replacing it with S, there has to be some changes in the distribution that we use. That is the student T distribution, which is this guy. All right. Any question about this, anybody? Is it too much information? Are you being able to get a handle of it? Okay. So now, Mijin, your part of the job is this. For the next problem, for these problems, how many problems are there here in this one? 2, 3. For this one, I already found it. So for this problem, Mijin, can you find the X bar and S sample standard deviation? Find X bar as sample standard deviation. Now, this is not for Mijin only, everybody. Now, honestly, I'll give you a few minutes. I think it's worth trying. Spend 5 minutes, everybody, 5-6 minutes trying to solve this problem. Exactly the way I did for the last one. If you want me, I can bring the screen back, okay? Oops. Hold on. So let's see here. You'd like to know how much time on the average students spend per day on Facebook. So you asked 15 randomly selected students and got the following data in minutes. Okay, this is what you got from 15 students. Create a 95% confidence interval for the average number of minutes a typical college student spends on Facebook. All right, so average number of minutes a typical college student spends on Facebook. Nowadays, Facebook is not being used by college students as much as it used to be many years ago. Now it's more like Instagram and Snapchat or TikTok or whatever. But the bottom line is social media, right? So I want you to try this problem. Everybody, try to find the sample standard deviation and sample mean. That means for this given data set, find the sample standard deviation and sample mean. And let me see, I'm going to bring back this screen. Can you read it? Let's move the problem a little bit down. You'll be able to read the data. Okay. I'm leaving it on the screen so that you can look at it and do the problem. So I'll give you 5-7 minutes. Everybody go ahead and work on it. Because I can do the problem myself, but that's not you doing it. I want you to try it, please. And then you'll run into problem and I'll be going over the problem. Then it will start to make sense. Oh, okay, this is what I did wrong here. So I'll give you 5 to 7 minutes to work on it. Everybody, please work on it and come up with a solution of your own. Make sure that you do work on it, because I'm going to ask everybody individually what you are doing and where you got stuck. So please work on it. Okay, so what do you guys got? Tell me now. I want to get some sense from you. So these are the numbers that you found from your survey. And the first thing you need to do is find X bar, that is the average of all this number. Remember, X bar is the sample average and mu is the population average. Also, we need to find sample standard deviation, which is S. S is the sample standard deviation and the population standard deviation is sigma. So what is the average for these numbers? What did you get? Somebody?
For X bar, I got 660.
Huh?
For X bar, I got 660.
Are you sure about that?
Yeah, and then I thought it was like super small, but then I tried to put it on the Swiftlet thing for the homework, and it gives it right.
660 average?
Yeah, and then for S, I got 19.899. And then when I put that one too, it's also right.
Who is talking?
Araceli?
Personally, okay. What you are talking about is not X bar. You're talking about summation Xi.
Oh, yeah.
That's not X bar. You have
Yeah,
to
but like,
divide by
I used
15.
the standard deviation calculator, the one you told us to go on like Google. And I put all of the numbers down. And then for the count, well, it's 15, right? Because there's 15 numbers. But then for the sum, I get 660.
So you have to take 660 and divide it by 15. And what do you get if you do that? That's going to be your average, right?
Yes.
Which would be what?
44.
44. Perfect. And the standard deviation is how much you got?
19.899. So 19.899.
19.899. 19.89.
Yeah.
I think everybody should have gotten this. Is that right? Anybody else got it?
Yes.
Okay. So good. Now, how about other people? Have you gotten it? Is it okay? Anybody else who is struggling to find the X bar and the standard deviation? Let's see. Jerry, you're the one who said that you needed to see it. So did you find it? Were you having any difficulties finding it?
Just the standard deviation, but it's fine. I mean, I'm learning now.
Can you do it on your own?
Yeah, I'll be able to do it on my own.
Okay. It takes time. Anytime when you're learning something, it's the same thing with me. If I'm learning something for the first time, it's difficult. It seems confusing and everything. Once you try it once or twice, then it becomes easier. All right. So that's your X bar and S. Now, what is my degrees of freedom? Which is always sample size minus 1. So it is going to be 15 minus 1, which is what? 14. That's your degrees of freedom. What is your alpha significance level, which is going to be 1 minus the confidence level, which is 0.95. So alpha is equal to 0.05. So alpha over 2 is 0.025. Okay, everything is the same. Now you should draw the diagram. So this is kind of like a stretched bell shape, which is t distribution. So on the right, we are going to have 0.025, and on the left, we are going to have 0.025. Okay. Now we need to find this value and this value. From where? T distribution. So this is going to be the negative value, negative. So let's write it down here, negative t sub alpha over 2, which is negative t sub 0.025. This is going to be t sub alpha over 2, which is t sub 0.025. And we are going to find these values from the table. Now let's go back to the table, everybody. T-distribution table, right? So let me just, oops. Let me just clean it up for the second. Now we are going to be exactly in the same column as before, right? Because area in one tail is 0.025 and area in two tails is 0.05. Good. Now the degrees of freedom this time is not 9, but rather 14. So if we look here, this is the 14, and if we keep going around this, we get 2.145, right? 2.145. So let's go back. So this is going to be negative 2.145. This is going to be positive 2.145. Now, if I do the calculation, my X bar plus or minus margin of error, right? That's going to be my confidence interval. Now, E is going to be T sub alpha over 2 times S over square root of N. T sub alpha over 2 is 2.145 times S is the standard deviation which you found, 19.89 divided by square root of the sample size, which is N. N is 15 in our case, okay? If I do the math, what do I get? Anybody got to that point?
11.02.
11.02, who is talking?
Araceli.
Araceli, 11.02. Anybody else got 11.02?
Yes.
Okay, great. So our margin of error is gonna be, our confidence interval is gonna be X bar minus E hat, comma, X bar plus E hat, right? Then my X bar is 44, so it's gonna be 44 minus 11.02. So just make it 11, a nice number. Don't do it for the online homework, though. I'm just doing it here to make it nice number. 44 plus 11. Okay, 44 minus 11 is 33, right? Comma, 44 plus 11 is 55. So from your calculations, you found that the average number of minutes that students spend on social media would be between 33 and 55 minutes per day. Okay, average number of minutes that students spend on the social media each day falls between 33 and 55. And how confident are you in your calculation? 95% confident. What does that mean? It means that if you were to take many samples of size 15, okay, from the population, if you were to take many samples of size 15 from the population, about 95% of those intervals that you create from, so from, you say, let's say you take 100,000 samples of size 15 each, and from each of these, you create 100,000 confidence intervals, right? About 95,000 of these 100,000 will include the actual population mean, which is mu. 95,000 of these intervals will include the population average. That means the average number of minutes that the students spend on the social media each day. About 5,000 of them, okay, out of 100,000, about 5,000 of them will not include the actual population average. That's what it means. So now it should make some sense, right? Is it okay, everybody? Any questions, anyone?
I have a question for the answer is not letting me in.
What do you mean answers are not letting you in?
The 3355.
Mhm.
It says I got it wrong.
Oh,
I
did
put
you?
Because he
32.
rounded up.
Yeah.
I rounded it. I told you, right? Don't do it for the exam, for the homework. 11.02. In the homework, you have to do exactly what it is. Then it will take it. So try 32.98. Okay? And 55.02. It will take it.
Okay, thank you.
Okay, it happens. Lots of information I'm giving you, and it gets lost in the process. Anybody? Any questions? Anyone? No questions? Everybody okay on the student distribution? In the exam, you should be able to, or in the homework, you should be able to identify which distribution are you going to apply. Is it going to be student distribution, or is it going to be z-scores that you're going to be applying? Remember, student distribution is when you do not know sigma, okay? Student distribution is when you do not know sigma, whereas when you know sigma, you use z-scores. That's what it is. All right, any question, anybody? No questions, okay. All right, so let's clean it up, screen. Let's go back to our problems. And Mijan, when I'm working on this problem, find the S and the standard deviation, sample standard deviation, S and the average for this problem. This one we'll be doing after working on this problem. So this is this one example, I actually did it for you, everything. So you'd like to know how many hours on the average students at your school work per week. So you asked 17 randomly selected students and got the following data in hours. So that's the number of hours that students that you surveyed work each week. So you surveyed 17 students, okay? And these are the numbers you got. These are the number of hours that they individually work each week. Now we are going to create a confidence interval, okay? X bar plus or minus E. Now here you have to be asking yourself the question, are you going to use z-score or t-distribution? To find out which one you use, you should be asking yourself the question, do we know sigma? Does it say anywhere in this problem what is the sigma? It doesn't. Anywhere in the problem does it say that what the sigma is? It really does not tell you what the sigma is. So you do not know sigma. If you do not know sigma, then you always use student distribution. By the way, one important fact here I would like to emphasize, so please pay attention. In real world, we use t-distribution most of the times. In the real world, you use t-distribution. That's the reality, because you really don't know standard deviation. you don't know what is the population standard deviation. In case you do, then you can use the z-scores. But in reality, you'll be using t-distribution pretty much always, okay? You may not have an idea what the population standard deviation is. So here in the problem, nowhere it says the population standard deviation is something. It just tells you this data. Another way to look at it, it'll give you some teachers or some books, they don't give the data, they just give you the X bar. They will tell you average of the sample is this and standard deviation of the sample is this. They tell you instead of giving the data. But I kind of like to give you the data so that you can play around with the data and come up with the X bar and the sample standard deviation. That way you will get your feet wet with doing the statistical calculations with smaller, really small data set. Then you can take this idea and apply it to bigger data set. All right. Now, what percent confidence we want? 95%. As usual, I have done the alpha calculation. Alpha is equal to 1 minus 0.95, which gives me alpha is equal to 0.05. So alpha over 2 is 0.025. Pretty standard. And how many people you surveyed? 17. So your degrees of freedom is going to be n minus 1. Oops. Degrees of freedom is equal to n minus 1, which is 17 minus 1, which is 16. So your DF or degrees of freedom is 16. That's what it is. Now, having said that, you need to go back to the table and look at the column where it says one tail, 0.025, two tails, 0.05. Okay, look at that column and then find the row from the first column that corresponds to degrees of freedom 16, right? Then you look at that value, and that value is, by the way, 2.12. That's what I found. Let me double check if it is right. I wonder if I made a mistake. Okay, student distribution, this column in 16, 2.12. That's right. So it's correct. Okay. All right. So that's what it is, 2.12. So your margin of error, E, is going to be T sub alpha over 2 S over square root of N. T sub alpha over 2 is 2.12. Your standard deviation of the sample is 8.38 divided by the square root of the sample size, which is 17. Sample size is 17. And if you do the calculations, you get 4.31. So your confidence interval is going to be X bar minus E, X bar plus E. X bar is 19.88, which I did the calculation, minus 4.31, 19.88 plus 4.31. That gives you a window or interval, confidence interval of 15.57 to 24.10. So that is your confidence interval. So you are 95% confident that the average number of hours that students at your institution work per week falls between 15.57 and 24.10. 15.57 and 24.10. Any question, anybody about this problem? Okay. Next, we're going to do the exact same type of problem. Again, I kind of want to do as many examples as I can. So this is the fourth example that we're going to work on. Exact same thing, guys. We are going to go ahead and find the confidence interval. And I'm using, again, 95% confidence interval. So you'd like to know how much money on the average students spend on coffee and snacks at your school. At your school. Schoolwork per month. This is probably an extra word. Okay. So basically, you want to know how much money they spend per month on things like coffee and snacks and everything, the students at your school. That's what you want to find out. So you surveyed 13 randomly selected students. So that tells you n is equal to 13. Okay. And you found this data. Based on this data, you want to create a 95% confidence interval for the average amount of money a typical student at your college spends per month on coffee and snacks. I like to ask students this question. Can you guys give me an idea how much you spend on coffee and snacks and stuff like that? Now that the school is not face-to-face or on campus, you probably spend less, but when it was, how much you spend per month, you think, on things like coffee, snacks, lunch money, this and that? Approximately. Any idea, anybody? Nobody wants to share that data?
Maybe 20 to 30 bucks.
A month or a week?
Probably like 200.
200, Alicia?
Yeah, I'd say about 200.
Per month?
Well, yeah, after a month, if you think about it, a coffee a day is about $5. You're spending, if you do coffee about 5 days a week, it's 30 bucks. Give another 30 to 35, 40 bucks in snacks of that week. It's like $70 a week times 4.
Yeah.
Oh,
Okay.
it's actually more because it'd be like 280. So
Okay.
It depends. It all depends. It all depends if somebody is a saver and goes grocery shopping, and I mean, varies. Everybody varies.
Okay. Anybody else wants to share the data? Because I try to get a sense of how much money you are spending on food. I mean, this kind of snacks and coffee. Anybody else wants to share? So, Mijin, you said 20 bucks per week or per month?
Well, per month, because I was calculating by what I would do. I wouldn't buy it every day. So I averaged it out like 3 times a week. I would buy coffee and I wouldn't always buy snacks because I would budget. So I just averaged it out to about, oh, I did that wrong, huh? It's 5. Sorry, I did it for the week. So 3 times 5 a week. So 5 times, that's 15. That's what I did wrong. Sorry.
So
My
what
answer
is,
is wrong.
so what is the total per month?
Per month for me?
Yeah, let's do it per week because I think I'm confusing. I'm making it harder for you. Per week, 20 bucks, you said, Mijin?
For me, I would say 15 to 20 bucks a week, and then it's probably about 60 to 70 a month.
Okay, 20 bucks. And then in Alicia's case, it's about 70 bucks a week, right, Alicia?
Correct.
Correct. Okay, anybody else wants to share? Jonathan, how much you spend?
Every month?
Per week, every week.
Just $10 or $15.
15. Anybody else wants to share? Okay. All right. So let's clean it up. Interestingly, it's surprising how much money you spend on things like coffee and this and that. I give business to Starbucks. I just buy the tall coffee. Tall is the small, right? So $2.25 plus tips. So if I'm in a good mood, I'll put $3, or if I'm not in a good mood, I'll put 25 cents. All right. So that's how much I spend, and I don't drink coffee every week, because if I drink coffee, I can sleep. So it's too strong for me. But when sometimes once in a while I drink coffee, unless I'm driving long distance. In that case, I'll buy coffee. Anyway, back to our problem. And by the way, I don't spend $20. I can assure you, everybody, I don't spend $20 or even $15 a week on coffee and snacks. I do not. Because I do the calculation. People, one of the reasons why people like young people, like especially teenagers and early 20s, or in some cases, people in their late 20s or 30s or even 40s, who knows? Particularly younger people. One of the reasons businesses love younger people, it's easy to get their money out of their pocket, because you buy a coffee. I buy the cheapest coffee. That's $2.25, right? Including tips and everything. Let's say it's easily on the average $2.75. Okay. So I think, hey, why am I gonna give $2.75 for a coffee, whereas I can buy coffee and make it? And that probably would be more better quality than what I get at the store. But Starbucks coffee is good. So you get the convenience and everything, and you pay premium for it. And with the COVID-19, the ambiance is not there either. You cannot sit down and enjoy the surroundings at Starbucks or wherever you're drinking coffee, and do work or something. You just drive, pick the coffee and go home, or walk in, pick the coffee and go home, or go wherever you want to. So that's the kind of thing. So I do the calculation. And nowadays with COVID-19, it's scary. One of the things you guys should be very careful. The price of food at a restaurant, it has gone up significantly since the starting of COVID-19, and it's not going to come down slowly, as much as it used to be in the past. This is called inflation. And I don't know if your class or some other class I talked about. I really, really don't want government to give money. I really don't, except somebody is suffering. Somebody lost jobs, they lost their income and everything. They need support. And for them, I want the government to give more than what they're giving. But if somebody who has job, you don't need to give them money. It creates inflation. But people, those who need money, give them more. And I see so many homeless people nowadays. It's crazy. I haven't seen as many homeless people. This inflation creates poverty, by the way, remember. It goes, the way it works, the money goes to the rich. It's not going to you. When you're buying Starbucks, no disrespect to Starbucks, I like Starbucks, but when you're buying this coffee at Starbucks, you are spending your money. Millions of people are spending money. Where did you get that money? By working hard, or you got it from stimulus check? Who's getting rich off of it? Starbucks shareholders, which is probably people who are already rich. So you are helping rich even get richer. That is the reality. So government giving money is never good. it creates inflation. It creates, your money is worthless. Let's say I have $1,000 right now in my bank account. I'm worried that my $1,000 value of my $1,000 is going down because of all of this. And it's the same for you, the value of your money going down. See, at the end, after the pandemic, which will be over someday, you'll be poorer. You didn't know, because government is not going to keep giving you money. The price of the things that has gone up is going to stay there because people have gotten used to it during the COVID-19, and the businesses are smart enough to figure it out. So psychologically, you are used to it, and as a result, what happens? You pay more. Now you're giving more of your money to buy the same thing. Okay, but your income hasn't gone up significantly. After the COVID-19, your income is not going to be 30% higher than what it is. Absolutely not. Your income is pretty much the same or lower because millions of people lost job, but the price of things are higher. As a result, you're poorer. So before COVID-19, if you made $1,000 a month, you could buy X amount of things with $1,000. But after COVID-19, you still make $1,000 and you're saying, I still have a job, but this $1,000 is buying less. So you're poorer. And this is something a lot of younger people don't understand. And they just go, hey, I gotta have coffee. Alicia, can I pick on you a little bit?
LOL. Well, now I'm thinking about it. I don't really spend $5 on coffee. It's like $4 with the tip, like you said. But
so people, the businesses love.
They're making money off of me. I'm not the only one, Professor. I'm the one that spoke out.
No, it's not a fault. It's not a fault. I'm
but
just
I understand what you're saying. That's so true. Like, I mean, after this pandemic, it's just downfall.
Yeah, for ordinary people, unless you have a lot of money, and I don't for sure, you should be thinking about it. You as an ordinary person, you have to think about your future, your family's future, your children's future. So you have to think about these things. And businesses love people like Alicia. She's spending $70 on snacks and stuff like that. They're like, wow, yay, you're so nice. And one of the things I kind of find quite funny and interesting is this. I don't smoke myself, but when you go and try to buy cigarettes or smokes from a store, they're very nice. Oh, thank you, this and that. But they're selling you poison and taking your money and saying thank you. Because cigarette doesn't have very many, or if any, good health impacts. So you're buying with your hard-earned money something that's harmful to you, and you're ingesting it in your body or smoking it in your body and feeling good about it. Somebody else is making money off of you. So it is so that's why you have to think about it when you make your financial decisions. All right. The reason I spent all this time talking about it is to bring awareness. I could teach you this problem and be done with it. Okay? But you go to college to learn and be aware, be educated. Okay? Unless you contextualize things, it's hard. Many years ago, you guys probably don't remember, back in 2000, did you know that gas was actually 99 cents? Gas was 99 cents, and that was pretty accepted. Then came Iraq war in 2004 or 2003, end of 2003 or something. Iraq war came in. Guess what happened? Gas shot up to $4.50 to $5 in California. This is California I'm talking about. Now, you guys, it has come down since, but now gas price over $3 is pretty normal. Oh, I got gas cheap. but gas was actually 99 cents. And within the last 20 years, by the way, in terms of technology and everything, to extract gas price should actually go down, not go up. With electric vehicles right now, gas price should even go down further, but it's at $4 or so. All right, so that's called inflation, by the way. It's the killer. Inflation is like killer, and it kills your money slowly but surely. All right, Mijane, what is X bar?
29.53.
29.53. And what is S, Mijane?
9.35.
9.35. Perfect. Thank you so much. Okay. Now, again, we are gonna try to find the average amount of money, create a confidence interval for the average amount of money that students spend per week, right? This is per week actually, not per month. So this is what the data. Now we don't know population standard deviation, so we are going to be using student distribution, and my alpha is 1 minus 0.95, so alpha over 2 is 0.025. I have done it many times, so no reason to do it again. And my degrees of freedom, how many data points do I have? 13. So 13 minus 1 is 12. So my degrees of freedom is 12. Now what we do, we kind of sketch it. .025, 0.025, right? And Mijane, did you find this value from the table by chance?
Yes, I got 2.179.
Yeah, I remember the value. I think that is about correct, if I recall it correct. 2.179. Now, how do you find this value? Once again, I have shown you 3 times already how to do it. You go and look at the table. Area in one tail is going to be 0.025. Area in 2 tails is going to be twice as much, which is 0.05. Okay, you look at that column, and then you look at the first column and go to the degrees of freedom of 12, and that's going to give you 2.179. And your margin of error is going to be T sub alpha over 2 times S over square root of the sample size. So, which is going to give you 2.179 times S is the standard deviation 9.35, all of it divided by square root of the sample size, which is 13. And if you do the math, you should get the following: 2.179 times 9.35, this divided by square root of 13 to the power 0.5 is going to give you 5.65. Margin of error is 5.65. So your confidence interval is going to be X bar minus E, comma, X bar plus E, which is X bar is 29.53 minus 5.65, comma, 29.53 plus 5.65. That's going to give you 29.53 minus 5.65 is 23.88, 23.88, comma, 29.53 plus 5.65, which is going to give you 35.18. $35.18. So So on the average, so you want to find out on the average, what is the student population at your college spent per week on snacks? And from your calculation, you found that, they spend somewhere between 23.88 and 35.18. And how confident are you on your calculation? You are 95% confident. And what does it mean again? If you created confidence intervals like this for many, many samples of size 13, sample size has to be exactly 13, then 95% of those intervals would include the actual average that the students spend per week on snacks and coffee, and about 5% won't. And I use the easy example. If you took 100K or 100,000 samples of size 13, right, and created 100,000 confidence intervals, right? You created 100,000 confidence intervals. 95,000 of those confidence intervals will include mu, that the population average, and 5,000 of them will not include mu. Okay, that's what it is. 5,000 of them will not include mu, whereas 95,000 will include mu approximately. And that's what it means. Any question, anybody, about this before I move on? No questions, everybody okay with it? All right. Since the exam is on Wednesday, I'm not going to start this new topic. This is the chi-square distribution. That means finding the confidence interval for population variance. Finding the confidence interval for population variance, chi-square distribution. Okay. We'll talk about it in the next class after the break, of course. Not break, after the midterm. Now, tomorrow we have midterm, so we will not be having our regular class like this. So you'll take officially, you're supposed to take the midterm during the class period, which is from 8:30 to whatever, 10:30 or 10:45. So what it is, I'm not restricting you to that window of time. I'm giving you the entire day to work on it, from 6 o'clock to almost like midnight.
You said tomorrow. Do you mean Wednesday?
I mean Wednesday. Thank you. Thank you. Is it Alicia? Okay.
No, it was Jerry.
Jerry, thank you, Jerry, for correcting it.
My name's not Jerry.
It's not tomorrow. It's the next class, which is Wednesday. So the midterm is on Wednesday. So Wednesday there will be no class. You'll be just working on the midterm. All right. And tomorrow, once again, the reminder: tomorrow we will have special office hours to help you out for the midterm at 6 p.m. Tomorrow is the 13th, which is Tuesday, April the 13th, on Tuesday at 6 p.m. We'll have office hours. And make sure to go over all the problems that you are having, I have assigned you, and collect them, all right? Don't come to the review session, let's see what my professor is saying. No. What you want to do, you want to go over the problems and find out which one you are having difficulties and make a list of it. Okay, write it down on a piece of paper. These are the problems I need help with, so that when you come to the office hours, you can quickly ask me those questions, and you already know in each of these problems where you got stuck. Okay, that way you will learn, as opposed to coming to the special office hours and let's see what he's doing, what people are asking. That's not how you learn the best. Go over the problems, not once, if possible, multiple times. Go over them and find out which ones you are really having difficulties and where are you getting stuck. What step is the stumbling point? And once you find it out, you can go ahead and ask me those questions, and I will go over those and answer your questions. And that way you will have the most and best learning experience, and you will learn. So in the exam, if you see a problem similar to this, you will be able to answer. Okay? Any question, anybody?
No.
All right. Yes or no?
No.
No questions.
All right, that's all for today. Thank you so very much. You guys have a wonderful day, rest of the day, and good luck with your midterm. And I will be talking to you tomorrow if you are joining for the office hours.
Thank you. Bye.
Thank you.
Bye.
Thank you.